In a simple sense, in Ruby, enumeration is the process of iterating over the items within a collection. So, for example, you know how to iterate over the items within an array. Very simple stuff. However, sometimes the items you iterate over don't really exist and are perhaps just abstract. So, this is a good example of that. And a lot of Ruby development relies upon iteration and enumeration, in particular, amongst all the different things you can do. It's such a key part of the language that we have the enumerable module that adds a ton of useful features onto the other classes that merely implement the each method. So if you have a class that implements the each method, it will yield for each thing within the collection. You include the enumerable module in and you get some really cool things. So just an example here, the any method. There's also things like map, first, just to get the first item off of a list or whatever. Include, does this collection include something that matches a certain requirement? Select, and there's a whole ton of things like that. So over time, a need grew for encapsulating the state of an enumeration itself within a separate class. So you could have an object and it just represents a state of an enumeration that's occurring. And work on an enumerator class began in earnest during the development of Ruby 1.9. It was partially backported into Ruby 1.8.7 as well, in the shape of a class called Enumerable Enumerator. So this is the enumerator class underneath the enumerable module. So you're likely to have had some experience with that, even if you haven't used the full-on, just regular enumerator class in 1.9. In short, the enumerator class encapsulates the concept of being able to iterate over a collection of data, and it provides us with objects that represent the state of such an enumeration. So I'm going to go 1, 2, 3 dot each, but I'm not going to put a block on the end. Where's the block? Well, we want to iterate over each of 1, 2, and 3, but there's no code block here. So what Ruby 1.9 and 2.0 will do is notice the lack of a block, and instead of performing an internal iterations, this is where each will go over each element and yield that element up to the block, it returns an enumerator object that proxies this array. Doesn't actually allow us to modify it or anything through that proxy, which is quite handy, but it proxies it and allows us to perform the iteration externally. So we can actually now do the iteration ourselves. We've gone through step by step using the next method. And once we get to the end of the collection, it raises an exception. And this is an interesting exception because it doesn't actually have the word error in it. It doesn't imply that there's been an error. Now, this is the way that we know an iteration or an enumeration has reached the end of the line, as it were. And we can catch this ourselves using a rescue block. I'm not going to do that. But one thing that is useful to know is that if you use the loop construct, it will catch it for us. And I'll use another little technique here, actually. I'll rewind the enumeration back to the start. I will create a loop, and you may think, well, hang on, this could just be an endless loop, but no, off it goes, and there's no exception, and this is because the loop actually catches stop iterations. Now, another technique you might see out in the wild is this, so toEnum. Essentially, it's synonymous with using each in this case, just telling you in case you see it in other code. Now, this isn't a complete Ruby course, so I'm not going to dig much deeper on this foundation. I just need to set a basis here. Just bear in mind that Enumerator has some other useful methods that are useful in working with the state of an iteration. So I've already shown you rewind. There's also peek, which allows you to see what the next thing is going to be without actually kind of taking it, as it were. Like so. There's also, with index, let's create an array of just strings, essentially. We create our each enumerator and our with index enumerator, and they kind of nest each other. And now if I do e.next, you can see that we don't just get back the string each time, we get the string and an index. So this can be handy if you have some kind of loop where you want to know what index something within a collection is, as well as the actual data itself. So back to reality now. Some things in Ruby support enumerators even though they're not in themselves enumerable, so strings for example. Which brings us to our first Ruby 2.0-ism of this video. So in Ruby 1.9 you could have done this. We'll create a basic string, this is the test, .chars for characters. and then we would have gone e.next. Whoa, what's happened here? Well, in Ruby 1.9, this would have worked. It would have returned, Charles would have returned an enumerator, you call .next, and you get exactly the same effect as we saw earlier. The same thing would have happened with .lines. But again, it's not flying on Ruby 2.0. So let me just show you what is actually going on here. Now we're in the multi-IRB environment, so we can see how it operates on different versions of Ruby. So let's try some of these. Let's try bytes, let's try chars, and let's try lines. Back in the Ruby 1.8.7 world, we get all the enumerable enumerators. In the 1.9 world, we get enumerators. But in the 2.0 world, we end up with something interesting indeed, which is that we just end up with very plain arrays. And in Ruby 2.0, string, bytes, chars, code points, and lines all return arrays, not enumerators anymore. And as an aside, this is also true of I/O objects, so be careful when you want to pull all the lines out of a file or something like that. But luckily, there is a way to keep it all working. You can use each char, each line, each byte, and each code point instead. So just demonstrating some of that for you. Of course, that's not going to work in 1.8 because it didn't have text encoding support. But as you can see, we get the same results on 1.9 and 2.0 now. So you need to be careful with this. If you're upgrading some code from 1.9 to 2.0 and they say, oh no, nothing's going to break, this is something that could break in your code. So make sure you run those tests and make sure you look out for this code. Moving on, ranges also support iteration in this fashion. So let's create a very simple range from 1 to 5. Da-da-da-da-da. That's kind of what we expect. So let's use this quality of ranges with enumerable select method to find all numbers between 1 and 100 that are equally divisible by 3 and 5. So we'll keep this very simple. We'll say divisible 5 is 0 and nums3 equals 0. And we find the numbers. Very simple. Now, is there a way that we could do this in a more controllable, more enumerator style way, more external type way? Whoa, this is pretty messy, but we are doing things in an external way now. So we're using .next, and we're doing everything manually by hand, as it were. Now, we could use the enumerator class itself and define a custom enumerator to deal with some of this as well. This is another way of doing it, and from an external point of view, it actually looks quite nice because we can just use loop in this outside section. And doing things with these external enumerators can be useful in situations where you don't necessarily want to perform every iteration up front, but instead of searching for something or working through a list of things and you may want to stop halfway through. So using an enumerator and the next and the peek methods, for example, you get the full control. But these techniques can all get a little bit too clever sometimes, and ultimately, wouldn't it be nicer if we could do something like this again? This is very clean, very simple to understand. Or, I can understand, maybe we do want to make sure that we get an enumerator object somewhere out of here, perhaps put a dot each in, we might expect it to work in a slightly different way. Well, unfortunately not. It's going to work exactly the same way and do everything up front. Its select, alas, is very eager to get its work done, and I choose that word carefully. Select is eager. In Ruby 2.0, you can do things the lazy way, all thanks to a new feature called Enumerator Lazy, which provides lazy enumeration functionality. Now, as an aside, it's been possible to roll your own lazy enumeration systems using some of those techniques I showed earlier where you create your own enumerators and things like that. You could also install a gem. There was a library that would allow you to do lazy enumeration type things for you. But this is now the approved, baked into the core feature. So this is the way to do things in future. So in short, a lazy enumerator will force Ruby to only execute code when it's needed, at the time of use, essentially, and only as many times as needed, regardless of where in the execution pipeline the code sits. Now, the main way that Ruby 2.0 lets you get access to this is through Enumerable's lazy method. So this is your typical enumerable type thing, like an array or a hash or a range, whatever. You call the lazy method and you get access to it, and any class that mixes in enumerable, essentially. And the documentation for Enumerable's lazy method says this. The lazy method returns a lazy enumerator whose methods map, collect, flat map, collect concat, select, find all, Reject, grep, zip, take while, drop while, and cycle enumerate values only on an as-needed basis. However, if a block is given to zip or cycle, values are enumerated immediately. Let's stop geeking out on these definitions though and actually see it in action. So we'll go back to our example with the 1, 2, 3, but we'll put .lazy on the end. Now you can see this looks much like before, but we have an object of class enumerator lazy back. So does this make any difference? Well, no, not really, because there's not much you can tell from this example. No big difference. But let's go back to the 1 to 100 conundrum from earlier. So let's add in our .lazy into here. What's going to happen? Well, now we just get back a enumerator lazy. What does this give us? Well, the methods that lazy enumerators support, which includes select, as noted earlier, do things the lazy way. So now we get what we wanted earlier on, and we can use it much like any other enumerator object. Ta-da! But we've managed to use this nice select syntax that we're totally familiar with. So that's pretty cool. Now, if we wanted the entire array to come back all in one go, we could do it with the force method, which essentially is synonymous with using 2a. So it can force things to be eagerly done if you need them to be. So all of this is something we quite desired earlier, but what about cases where this sort of behaviour is essential? It's not just something that's kind of fun to play with. Where would this be really, really useful? Let's say that we have a range that's infinite. Some people don't know that this is possible, but it totally is. So we're going to create a range here that goes between 1 and infinity. That's all pretty good so far. And let's create an enumerator upon that. We can go through 1, 2, 3, 4 and all the rest. So far, so good. But what if we want to iterate over this infinite range, looking for numbers that divide equally by, say, I don't know, 74 and 13. And luckily I have an example prepared earlier, which I can copy and paste. So we take our infinite range, we use the select method, and we try and look for everything that's divisible by 74 and 13. Well, if I press enter now, it's going to sit there forever because it's going between 1 and infinity is infinite. We're never going to reach that limit. So, Control C out of that. What can we do? Well, instead, take the code that we just had, use a lazy enumerator instead, and, in fact, I need to assign this to a variable, and bam, off we go. So, this is just a really cool way of doing calculations in a very functional way on something that's infinite. So we didn't want all the results up front, we only want them when we request it with next, and bam, off we go. Now, of course, if I did something like e.force again, we're going to have the same problem with it hanging, because it's an infinite range. So what about something a bit more practical than this? Mersenne primes are prime numbers that are 1 less than a power of 2. So 3, 7, and 31, for example. Now, coupling Ruby Standard Library's prime library, which is really a specialized enumerator that finds prime numbers on the fly using various techniques, coupling that with some lazy select magic, we can detect Mersennes of our own. And bear in mind that only 48 have been found so far, so don't expect miracles here. So what we're going to do is we're going to load up the prime library, and we're going to get hold of the prime enumerator, which is using the Eratosthenes generator in this case, which is a kind of a sieving technique. Don't ask me too much about this, it's not my strong point. But we can get access to primes, so that's pretty cool. So now what I'm going to do is I'm going to turn this into a lazy enumeration. So we don't want to get every prime number ever, because that will never complete. We'll use a lazy enumeration, and what I'm going to do is use a little bit of a kind of a mathematical approach here. We are looking for the number plus 1, so we want the number that's 1 up from our prime we basically want its log 2 to be an integer. And we can do this in Ruby using this kind of trick where you do modulo 1, which gets rid of everything after the decimal point, and comparing it to 0.0. So just in case that doesn't quite add up to you, you can either try messing around in IRB and see exactly what I meant by that, or basically just trust that this will return true when the p plus 1 is a power of 2. So there we go. We have our Mersenne lazy enumerator, and we can do this. So we get 3, 7, 31, 127. And we could go on. Now, bear in mind that 524,287 was discovered in 1588, so we're doing some real modern math now with our Ruby interpreter. Now, the next one is over 2 billion. It was discovered in 1772, but it will take Ruby a rather long time to find that, so we're not going to carry on. Now, along similar lines, there's an example included on the Ruby issue tracker with regards to implementing lazy enumerators that took a slightly different approach. So this code does things the other way around, and it uses an infinite range like we had earlier, works out the square of each number, adds 1 to it, checks to see if the value is prime, because it's actually doing something slightly different. It's not a Mersenne prime. I'm not sure what it's called when it's a prime that's square plus 1, but either way. This is a different approach, but a beautiful demonstration of how lazy enumeration can help you write things in a more direct and functional way. One thing to note here is that the take method is lazy itself. So if you have something that's a lazy enumerator and you do not take 100, you don't just get back an array with 100 things in it, you get back another enumerator. So you can either then use .force to get hold of the results, or you could use the first method, which can also take an argument if you want it to be totally eager. So just to give you a very basic demonstration here, this just returns enumerators. If we want to get back an array, we use force, or I could just change this to first, and we get exactly the same result. The file class supports enumeration too, and also lazy enumeration, very handily. So let's say that we want to browse a really large file, and we're going to use my 1 megabyte text file of bookmarks. I know that's not very large, but we're going to go through that and look for the first bookmark that mentions Rails. So here's a very naive way of doing it. We basically have the file name, and we read all of the lines into a giant array, and then we use detect to find the first line that matches this regular expression, which is Rails. So very, very simple. Well, 1 megabyte is no big deal, but say like it was 100 megabytes or a gigabyte or 100 gigabytes, it might start getting really slow and memory hungry because we're reading everything in to an array. Every single line is becoming a Ruby object, it's becoming a string, and it's just a big mess. So lazy evaluation lets us get a bit smarter here. What we do now is we just open up the file, so that's very simple. We immediately go for a lazy enumeration and we detect. So it only does as little as is absolutely necessary to get things to work. And we can run some benchmarks to prove this point. So here we go. We load in the benchmark library from the standard library. And what we're going to do is do 2 different reports for eager loading and lazy loading. And 400 times we're going to repeat this same thing using the eager approach, where it reads everything into the array, and the lazy approach, where it uses the lazy approach. So let's run this. Now you can see the difference here. The eager way takes, we use the real time, uses 1.6 seconds essentially. The other uses, 0.05 of a second. So this is far from a scientific test due to the role of caching, it's played here, and we've only run each test once and things like that. But the magnitude involved should really demonstrate the difference here between the techniques, so there's a big win there. Another big win for lazy enumerators is how you can chain them and get more expressive code without an immediate performance headache. So my bookmarks file works by having the URL be the first thing on each line. So it'd be nice to split the line by spaces and then grab that first thing off of each line. So we could do this type of approach. And I'll show you, this is the eager way of doing it. So it will go through each line, do the split, and so on and so forth. But you could make it so that everything's lazy and you do things in a much more efficient way, essentially, if you only want to step through items one by one. So we've looked at how you can get performance improvements for certain algorithms by using lazy evaluation. But on an apples-to-apples comparison, the lazy enumerator objects act as a proxy in between you and your data. So they do have a non-negligible performance hit. So let's do exactly the same task in the eager way and the lazy way and see the performance difference, just a completely raw speed test. So we're going to add together all of the numbers that divide by either 3 or 5 between 1 and 10 million. So that's all this does, very simple test. So let's give it a go. So the eager approach has taken, say, roughly 1.5 seconds. The lazy approach has taken 2 seconds. So there is a difference there. Sometimes you will see more of a difference in magnitude. I've seen people reporting online seeing 3 to 4 times difference. Whereas in this case, not quite so bad. But just be very careful with this. Don't assume, like some people have, that why don't we just use lazy enumeration everywhere? And the reason is it does add another layer in between things that you may not want. So don't use it absolutely everywhere to cover all of your bases. Use it where it's needed. So that's it for our overview of Ruby 2.0's lazy enumeration functionality. It has a lot of promise as a technique for avoiding external iteration techniques in many circumstances, and also encourages a more functional programming style using methods that we already know and love, like select and map. And we also get the ability to tie them together without getting their typically eager properties involved.